What I want to know and what the feedback I want to get from you guys is, do you feel you know what I mean when I say the projection of one vector onto another? If I asked you to draw that, in fact, let's do that now that I've asked you not to take pictures. Draw me what you think I mean by the projection of one onto another. So let's say the projection of A onto B. Okay, this is heartening because I've walked around and pretty much everybody has drawn me two different types of diagrams. The first diagram I've seen is this one. And then you've gone and said A, B, and the projection of A onto B. And the other diagram that you've drawn, which is equally valid, is where we have A and B connected. So that's great, because we can start from that. Now, if we have this, I know we're in vector land, but vector land is based on our geometric understanding. So in our geometry world, good afternoon, Varshan, we know that we can actually work this out with this angle. We worked our way through to getting to this formula. We have our A dot our B unit vector. No, it's not the way you like it. And then we said that gave us what? We called it the scalar projection. It's the projection of A, but in a magnitude only. Then we needed to multiply it by the direction of B. So all the other versions that I put underneath, which is where I think that we started getting very confused, are all just different versions of these ones using those properties that we had at the beginning of the lesson. So I want to do a worked example how I would do one of these, because I did say I was going to show you in one step, and now I want to show you how I would do this. And then also not just how I would do this, but what this looks like. This question says show that the projection of A onto B has a length of 12 root 2 over 5. So this is our question. There's a lot in this question. So we have a series of things that we could do to start, and I'm going to suggest that while we're learning, let's start by drawing up what this is. So can you all very quickly draw me position vectors of A and B, and as accurately as you can, although I'm not going to be able to do it dreadfully accurately on the board. If you've got that drawn up, I'd like you to draw me the projection of A onto B. And if you guys have a ruler, and I didn't use a ruler, but if you have a ruler, you can actually use it to work out a right angle. The right angle is the important bit there. Show me the projection of A onto B. Alrighty. Did you get something that looks like this? Okay. On your calculator, because we have this question, we're going to work through it. Can you tell me what 12 root 2 on 5 is approximately? 3.4? Having a look at yours, could it conceivably be about 3.4? You've got it much, yours is exactly 3.4. 3.8, I'll accept that out of a diagram. So what we're being asked to show is that this length is 12 root 2 on 5, which we could show by diagrams. So what we want to do now is figure out how are we going to work our way through this. What am I needing in order to find this? What would I need to do? What's your first instinct?
Find the angle between the two.
Your first instinct might be to find the angle between these two. Agreed? Is that difficult or hard? If we found this one, it's just cosine. Do you agree? Yep. So if we knew what this angle was, we could actually work it out. To find that angle, we could do this angle and this angle, and we could actually work out what that angle was. So if you forgot all your formulas, you can still do this. Do you agree? Let's see how using the dot product and this methodology helps us a little bit. But I wanted you to see that if you'd actually drawn a diagram and gone, well, I can do this, look, that's pretty easy, and that's pretty easy, and then that's 90 degrees, I can do this. You need to be exact, and sometimes that gets a bit tricky. This helps us to be exact with really tricky numbers. Do I need to know what direction it's heading in to find our magnitude? No. Would it be useful for us to do a dot product? Remembering what the dot product is? Yes. So can we work with A dot unit vector B? Yep. I'm going to start by saying, well, and I know I write it and then I erase it. Let's work out what unit vector B is. What's a unit vector B? Loudly. B over the magnitude of B. What is B over the magnitude of B? Because we haven't done it in column form before. How am I going to do this? Who wants to talk me through? So it's 1 minus 7, over square root. What's this? We okay so far? I need to now do a dot product. So when I do the dot product of A dot vector A, unit vector A, when I write that out straight away, I get 10 minus 2. Don't write this, please. Dot 1 on root 50, 1 minus 7. And this is fine. But we learnt from our properties of vectors before, this here looks a little more complicated. We like it when it's a dot vector. Do you agree? What can I do with that constant?
Pull the scalar out.
I can pull the scalar out. We learnt that from our multiple. So you guys can write this line. Yeah, except not with a minus 10. All right. Can you do this? Go for it. All right. And what did you get?
24 over root 50.
Maya, what did you get? How did you simplify it? Rationalize the denominator. And when you rationalize the denominator, what did you get? What did you get?
Oh, the final answer of 12 root 2 on 5.
What were we asked to do?
Find that.
Have I proven or shown that the projection of A onto B has a length of 12 root 2 on 5?
Yes.
Otherwise known as the scalar product, or the scalar projection? Yes? And notice how I've not really gone near this formula, but I've used my understanding of this formula to say, well, I don't really care what direction it's going in, so let's cut that vector Now I'm just using the dot product. And this one I can work with. Are we okay with that? All right, I've got 2 last points before I set you to do your work. I want to talk about 2 special projections. The first projection I want to talk about, do you have a question?
Yeah.
Yep.
That's 12 root 2 on 5, right?
Yep.
That's projection A onto B. The formula was...
Vector projection.
It times the unit vector of B again.
Why, you're asking why this one is the unit vector? Or we didn't use this formula?
Yeah, no, but like, why does that equal to that when...
Okay, so if you did this formula, in fact, really good question. If you used this formula and said the projection of B onto A equals A dot B hat times B hat. And you went, I'm going to find what this is. We've got this bit.
Yeah.
So that's 24 over square root 50 times the direction of B, which is 1 minus 7. No, it's not. It's the unit vector. So it's times 1 over root 50, 1 minus 7. This is the vector projection of A onto B. If I work this out, I get 24 over 50 in the direction of B.
So that's the scalar, that's the vector.
So now if I asked you to find the magnitude of the projection of B onto A, I've got this.
Yeah.
How would I work out the magnitude of this?
Oh, yeah.
You would go 24 over 50
Pythag.
times and we end up with, magically, the same answer. Okay? Really good question. Because you can just go, what I have. What I'm wanting to get to you guys is, yesterday we got a bit muddled in formulas. You know I'm not great at formulas. You can opt out. You can opt out of vectors entirely and just go geometrically. If you're in an exam and you're stuck, draw a diagram. See if you can use something that you know and modify it into something that answers the question. And you do that by knowing that the only reason we've got the B hat outside is to give it a direction. But if I forgot, well, that's okay. I'm now finding a magnitude, and this I can do. Are we okay with that? All right. Last 2 points I wanted to raise were 2 special projections. And I'm going to give you a second. I want you to raise hands. I don't want you to call out. I'd like you to tell me the answers to this. Think about these 2. If you think you have an answer to one or both of them, raise your hand. If A is parallel to B, what is the projection of A onto B? And if A is parallel to perpendicular to B, what is the projection of A onto B? Don't overcomplicate it. We're talking shadows. If you think you've got it, raise your hand. If you think you need a diagram, do that. I've got a smattering of hands and a very fierce argument happening, which I love. I'm going to give them a second to resolve. Do you think you have it? No, don't give me an answer. Do you think you have it? Okay, going to ask you your gut feel, okay?
Whatever you're projecting on the side.
All right. Are we okay? Do we have some consensus? Tarun, you said, I don't really know how to explain it, but what's your gut feel for the first one?
So for the parallel one, they're constantly going to be at right angles to each other. So
First one's parallel.
So they're going to be constantly right angles to each other.
Right angles to each other?
Oh, wait, no.
Nice thought. Go back and think. I saw a lot of you doing this. It was great. It's like walk like an Egyptian. Right. Does anyone else want to have a go with our parallels? This corner, and Josh very quickly convinced Ariana. So go for it.
I think it's vector A.
You think it's going to be?
Okay, so what I said was if I have vector A and vector B, and I just push vector A onto vector B, then it's vector A.
We still have vector A? Does it change its anything? No, not really. It's just gone boom.
What is vector B smaller?
You can copy.
Again, if my vector B is smaller, it just sits in. It's still got this magnitude on that length. So that is where the shadow falls down a little bit. If it's smaller, then it's entirely in the shade. Oh, if A is smaller, still vector A in that direction. It only casts a little shadow.
Wait, if this is B and this is A.
If this is B and this is A, and B and A, so A is smaller, the shadow cast by it is? If B is smaller, are you ready? What's my shadow of A?
Oh, I'm so stupid.
No, not at all. You're like, no, this doesn't make sense. Are you happy with that being A? What about this one? What's the answer? It's 0. What's the shadow going to be? Going to be not very much. Are we okay with those two special properties? All right. I'm about to write up what we're doing. I liked the debate down here. Was there a question that came out of it? No? Yes. For this one? If B is bigger than A. B is bigger than A. What's my shadow? If A is bigger than B, what's my shadow? Nope. It's just entirely in the shade. Are we good? Good questions? Pavani, you'll be happy to know we've just re-clarified your question.